So on to topic 7, where we're going to revisit free body diagrams and do some more challenging problems with it. So in here, I'm going to page 30 in your blue packet, and there's a lot of different scenarios here, and we're going to use Newton's second law of motion, F equals ma, to try to fill in all the blanks that are here. I am going to recommend that you use an additional sheet of paper to help you work your way through these so you have all the steps. And what I'm going to do is I like to group them in ones that are very similar to each other because they've provided similar types of information. So what I'm going to do right now is we're going to group them together. I'm going to give you kind of an outline of what to do, and I'm going to recommend that you pause the video kind of after each group, figure them out, and then we'll move on to the next group. And later on in the next video, I will go over the answers and the solutions. But I think it's really good for you to make some attempts to try to work on these before I give you the answers. So the first group I like to try is A, D, and H. And the reason I like to do those first is because those give us all of the forces drawn in with numbers on our free body diagram. And then they ask us to fill in M, A, and the net force. And I think these are the simplest ones. These are just like what we did on the previous page. And so I think these are the easiest ones to start with. So kind of your steps for doing these is that I want you to look at these free body diagrams and figure out what the net force is by subtracting forces that are on opposite sides. So you're going to be able to look at this first one for A and figure out what the net force is. You should be able to look at D and see that it's balanced up and down, but it's got some kind of net force over here to the left. And similarly for H. So once you have those net forces, then the next step is to find the mass. And we learned earlier in this chapter that weight and mass are related. So if you multiply the mass by 10 meters per second squared, you will get the weight. And since the weight is the force of gravity, what you're going to want to do is take the force of gravity and divide it by 10 in order to find the mass. Okay, so just like we did in the previous problems. And then once you have that, you're going to use the net force equals mass times acceleration to find for A. So A is going to be equal to the net force divided by M. So pause the video, work through A, D, and H since they're all very similar, and I will go on to tell you about the second group. So now the second group I do is I kind of just go in alphabetical order here, that B and C look very similar. They gave us the mass and the acceleration here, but they did not give us the forces or the net force. So the first thing that you can do, you can take the mass, multiply it by 10, and find the weight, which is the same as the force of gravity. Then you can also use mass times acceleration to find the net force. So the net force equals mass times acceleration. You can fill that in. Once you have those two, you know the downward force, you know the overall net force, you know the direction of the net force, you should be able to fill in what the upwards air resistance is. So you can do steps 1 and 2 in either order since you already have both pieces of information. It does not matter which order you do them in. But I'm going to go ahead and walk through B with you just so you can see. So for letter B, when you find the weight, it is going to be this 10,000 kilograms times 10 meters per second squared, which is going to give us 100,000 newtons down for our force of gravity. For step 2, F net equals M times A, we're going to be multiplying this 10,000 kilograms times 8 meters per second squared down. So we're going to get 80,000 newtons down. So in order to determine what F air is, we need to compare these upward and downward force in respect to what the net force is. So since the overall net force has to be 80,000 newtons down, we know that the force of gravity has to be bigger than the force on the air. So in order to get this, we're going to have F air is going to end up equaling 20,000 newtons. And you can verify this by looking at the fact that the gravity is 100,000. If we say air is 20,000, then we're going to be left with the gravity equaling 80,000. So take a few moments and think about that, because this is one idea, concept that sometimes students really struggle to see. There's a few who are very mathematically inclined and it clicks really fast, but other students really have to sit there and think about it. So take a few moments, pause the video, kind of work through it, make certain that you are okay with it. And if you aren't, please send me some questions. And then you're going to do C exactly the same way. So pause the video before you move on. So the third group I go through is looking at G and I, because they are similar to each other. Again, they've given us the mass and the acceleration, and they've given us enough information to do what we did for B and C. So you're going to use your mass to find your weight, which is also known as the force of gravity. You're going to use your mass and the given acceleration to find your net force using Newton's second law of motion. And from all of that information, you're going to be able to go ahead and fill in the rest of the forces, okay? Note here that since there's an acceleration to the right, we are going to be able to figure out the applied force very quickly. Since there is no acceleration up and down, you know you've got to be balanced here on G. Same thing's true for I. Because the net force is to the right, you're going to be able to use this applied force and the net force to figure out the force of friction, but it is balanced up and down, so you'll be able to figure out exactly what gravity and normal is. So pause the video and work through those. Then the last ones, E and F, they're similar to the others, but they're just slightly different. And so you're given slightly different information, but see if you can kind of piece your way through it. Because remember, you're using the same kind of three ideas here. You're using F equals ma in order to solve for parts of it. You're using your free body diagram to see if you can determine what the net forces are. And using mass times G of 10 meters per second squared, you can always figure out what your weight is. So I'm going to go over the answers in the next video.